So I'm going to make a folder called week 2. We're going to go through how do you figure out a program? I call it workflow. Because you can figure out every program in the same sequence with the same stuff. And if you do things consistently, then every time somebody hands you a requirements or a job or say, hey, I want this, you start into your normal workflow, and at the end you have a program. We don't want to have to change how we do things every time we do something. I'm going to create a new file that says leave a tip. And by the way, do you know who Laurie is? She is one of my sisters. She's the oldest of the 3 sisters, just FYI. Sometimes I put student names in these. Sometimes I put family names in them. There's always a story behind each one of them. So all programs have input and output. And one of the things that we've started looking at is we have 3 different types of input and output in all computing programming languages. And we're talking about the keyboard and the screen. Those are what's considered the default input, and the screen is considered the default output. When we enter something from the keyboard, right? If we do input, this is going to be a question, and I say, whoops, I have to do it right, don't I? T, there we go. If I say, enter food charges, right? So that's what it says, get the food. Oh, I have a little to-do. Let me put that in there. That'll make it easy, won't it? I pre-planned it for you. Let's copy that. There we go. Control C, Control V. And then let's move this up to here because we're getting the food charges. Okay. There. Yeah, I know it's magic. It's also too small, isn't it? So I went to this guy on the web.
Oh.
And I selected it with my mouse, and it's a PDF, so sometimes it kind of wiggles, but I just went like that. Now, Control C, Control V, I'm done.
I thought you had maybe like macros going on.
No, I'm just using keystrokes. There's no macros, there's no nothing. I selected it with my mouse because this is not a document you can edit, but you can drag your mouse through it. Once you've got it selected, Control C will copy it. And then I pasted it in here. And then I selected, cut this out. Oh, I didn't ever paste it, did I? There. Oh no, I lost my code, didn't I? It's not going to be hard to do it again, but I hate to do things again. There it is. So I must have done something. Oh, that's right. I copied on top of it. So unless you turn on the multiple clipboard, which I haven't done, you can store one thing in the clipboard at a time. And the minute you copy or cut, that's replaced. So I'm getting input for food charges. What type, and in computer science and programming, we call this data type. What type of data is this? And at this point, we have 3 that we're working with. We're working with text, which is called strings in programming talk. We're working with integers or whole numbers. We're working with floats. What type of input is coming out of this? Is it a string, an integer, or a float?
Strings.
String. What do we want it to be?
Float.
Yes. So how do we do that? You don't have to memorize it. We do this little guy here. We surround that with float. So how this kind of works is the first thing that happens when this line runs is it prints out enter food charges. And then it sits and waits for you to type in text from the keyboard. That's what input does. Once the input is done and you press the enter key, it goes to this and converts it into a float. And the result of those 3 things we want to store in another variable. So since I said food charges there, food charges would be a good name for a variable. And I got stuck in the last class a couple of times trying to come up with a good variable name. So the sequence of this is it prints the prompt. So everything works from the inside out. It prints the prompt. It's waiting for me to type in something. I type in a 10. The input, we don't see that part happening. But when I press enter, it comes in as a string. Immediately, after it comes in as a string, it's converted to a, oh, I have to bring this bigger, don't I? It is converted to a float and that's assigned to food charges, but we can't see that, can we? Yeah, it's just like nothing happened, is it? Yes.
Yesterday I did something with Python. I was having some problem.
So we have our food charges. And basically I outlined the whole program for you, and this is way too easy, isn't it? So I've done that part. Is there anything else I need to do for that?
Mm.
Okay, so I've started adding in something that we've not worked with much until this point. These are called constants, meaning they are constantly the same for the entire program. They do not change. If, and the reason for constants is I type this in, what does that mean?
The tax rate.
How do you know?
The equal.
Let me do this a different way. If you just see 0.18 in this program, how do you know what it is?
Well,
And how did you know what it is?
all I know from that it's an integer.
No, right there, you said it's the tax rate.
Oh,
If I just type in 0.07 in the middle of the program, like if I'm multiplying the food charge times 0, what is it, 0.07?
that's tax rate.
And you only know that because it says tax rate up here. I say tax rate in my documentation, but if you had none of that, what would 0.07 mean? It's just what's called a magic number. That's what we call it in programming and Excel. Magic numbers meaning it has no meaning, and how Ignacio got meaning out of it is from this constant. So we don't use the number, we use the name. And if later the tax rate changes, which it does, and you decide you want a higher tip rate, we just have to change it here, and it changes in the rest of the program, no matter how many times we use tax rate. So constants serve two purposes. We know what the number means, no magic numbers, and sometimes you'll get a comment from me saying, yeah, no magic numbers. I don't want numbers out here that don't mean anything. And the other thing it does is we can easily change everywhere the tax rate is by changing this. I change that to 0.06. Everywhere else tax rate is referred to changes. And a constant means that it doesn't change unless I change it here. This is a variable, which means it can change as we go through the program, which is fine. And we need both as we're working. All right, since we need both, we've introduced constants. They don't change. They're for documentation. Comments are good. Is it to do a comment? Absolutely. Do comments all have to look the same? No. Comments are typically above the line that it's explaining. And you can leave the to do in, you can take it out, whatever you want to do. One of the things that is good to do when you're doing your code is separate things by pressing the enter key. If all your code is like this all together, as it gets longer, it's harder for me to figure out where things are. And so it doesn't hurt to have spaces between things because Python is going to run it exactly the same. If you have bunches of comments and you have bunches of paragraph marks in between things, it doesn't matter. It's going to run exactly the same because when the program is run, all that gets thrown away and all that's actually executed are the executable lines. All right, so food charges times tax rate would give us, what would it give us?
Oh.
Help me out here. Sean said in the last class, Caleb knows what I'm talking about. Somebody else? Somebody? If I multiply the food charges times the tax rate, what do I get back?
The meal price?
I didn't hear what you said, not mine.
0.0126.
There. So this would be the food charges, whatever I've typed in, times the tax rate, which would give me the sales tax of my purchase.
Oh, okay, so I thought you meant like we like timesing 0.07 times.
We are.
Oh, no, I'm saying I thought that's what the question that you wanted.
Oh, no, we are multiplying it, but we're not multiplying it by 0.07. We're multiplying it by whatever the tax rate happens to be that program run. If next month the tax rate changes to 0.07, I would send out an update like TurboTax or whatever, your apps on your phones, and I would ship out an update that fixes that and changes it to 0.08. And I only have to change it once. But tax rate at this point is 0.07. Well, it might not be in a month.
Sure,
Make sense?
makes sense.
Well, now it's getting way too easy at this point, isn't it? We know how to do the rest of this. Right? Any problems with the rest of this? That's way too easy. Calculate the meal price. I give you the formula, calculate the tip. The tip is not taxed. Well, that's good. Will the tip be taxed at this point if you multiply the food charge times the tip? No, because we calculated the tax up here. So the tip doesn't get a tax. The total would be the food charge plus the tip. We can print these all out because they're all stored in variables up here. Yes, everybody agree? I'm not fooling you? You're right, I'm not. So this program follows the input, right? Constants are part of your input. You just don't type them in. Here are all of my calculations. And then this is my output. So every program we do is going to be divided in those three major things. We're always going to have some sort of input, some sort of calculation, some sort of output. Yes.
I just wanted to ask for the sales tax one. Can we treat that like multiplication, like food charges times tax rate or
Mhm.
tax rate times food charges? Like,
Mhm.
does it? Okay, so it doesn't matter of the orient.
Oh, no. Unless the only time the order matters is if you're like adding something and you have the order of precedence. And then I say put parentheses around it.
All right.
And I didn't put parentheses here to be an order of precedence. I just was singling out that this is the algorithm, the thing that you're doing. And I'm making it more obvious at the beginning because, you know, the first time you learn a programming language, it can be quite a bit to figure out.
Thank you.
Nope, it's just like in math. If you have 1 times 2 or 2 times 1, doesn't matter. We just write it differently in programming, but the math concepts hold here. But we write it with big words that describe things, where in math, you have X times Y equals Z. In our case, we do food charges times tax rate is assigned to sales tax. But the mathematical rules still hold. Trigonometry rules, calc, whatever. It's the same stuff, we just do it backwards and we give names to things that people can understand later. Because this is an application of math for programming.
Thank you.
Sure. Questions on that? I think it's pretty easy to finish that out with for now, isn't it? Now, one of the things, did we introduce F strings? Oh, we did introduce F strings, okay. Oh, and I didn't give an example of F strings in this. When you're starting with F strings, it's handy to have an example because it's really hard to remember what goes where. I just did, I haven't done that for a while. In my last class, I had to fudge around until somebody could remind me what it is. So let's print out the, we'll just print out the tax. When you put an F in front of that, it's like saying, I want to format this string and make it look pretty. So F string is short for, I think, format strings. If we just print out calculations, we could end up with all kinds of decimal points over there. And F strings allow us to make it look nice. So if I am printing the sales tax, it's nice to have some way to make it look pretty. I like things to look professional. So if we put in curly braces is one term for them, but the little squiggly things that are, where are they at? Above the enter key on the left right hand side. Yeah. That says to the F string person or to Python, a variable is coming up. And I want you to put in that value in this spot. So our value is going to be sales tax. And when you're using Visual Studio Code, see, I do things, I don't even think about it. As I type in sales, see how it like hunts through and finds it? If you've declared a variable up here and you put it in here, it knows, oh, you're looking for a variable. And so it'll start searching and finding things. That's not AI, that's just called IntelliSense. That's something Microsoft does. And other programming things do the same thing. That's just Microsoft's word for it. It's basically doing a quick search algorithm trying to say what matches sales tax. So if you're at this point, notice there's a highlight on sales tax, tab will complete it. And if you want the real term, that's called tab completion. That way you don't have to worry about spelling it right. You just have to get the first parts. You know, as I type S-A-L, well, there it is. I can then press tab to complete it without any misspellings. That's another handy thing. Colin says, uh-oh, something's coming up. We're going to do something for this with our F string thing, right? We're going to put in comma separators so that if we have 1,000, it does 1,000. In some countries, it'd be 1.000, which I've always found confusing because it looks like a decimal to me. But many countries do things different than we do. And of course, we do things in the United States the best, right?
Mm,
No, I was looking at you. Do we do the things the best in the United States?
Yeah,
Not
something.
necessarily. No, we do some dumb things.
Yeah.
We are still on,
Something like really good, something.
one of the dumbest thing I think we're still doing is we're still on the imperial system instead of the metric, like the rest of the entire world.
yep.
Yeah, that's dumb. Why are we so special? We're not. Okay, that completes it. Sorry, Trinity, were you saying something?
Yeah, I was gonna say there's two other countries that don't use the metric system too.
Who is that? I can't remember.
I don't
They're like-
remember, but they have different versions of Imperial.
Right, but they're like little tiny countries, if I remember right.
Uh-huh.
Yeah,
Mm-hmm.
and it makes no sense to me. In the 1980s, when President Carter was in office, he started working on that. And if we'd have kept going at that time, we wouldn't even know the difference. We would be metric like everybody else is. As Ronnie would say in her class, says, yeah, it's not my problem. We've been using metric all this time. You guys have to figure out the conversions, you people in the United States. Because she's from, oh, I can't remember where she's
Sri
from.
Lanka.
Sri Lanka, yeah, from Sri Lanka. Says, yeah, that's your problem. Okay, so enough of that. This is not a political class, but this is like, why in the world do we keep going with these old things? Yeah. All right, so if I back up, you put F between the double quotes, everything is between the double quotes. This is the way we'll format everything. There are other ways to format strings and make them look pretty. This is the most modern version in Python. And I think the easiest once you learn it, the hardest part is remembering all these little wiggly things. Just go back to an early problem when you used it before to remember what goes where. So the colon says there's going to be formatting coming back up. Comma means we do 1,000. This means we're going to display 2 decimal places in a float. Float meaning floating point, because we can't represent the analog world digitally exactly right. Because if we divide 1 by 3, what do we get? 0.3333 out till the end of the universe, isn't it? There is no exact 1/3 in decimal. I mean, in digital domain. We can get close, but we can never get exactly right. So that makes it look pretty, and that's the one we'll be using for everything that we do with all my classes. We'll always format our numbers like that. There are other ways, and you'll see other ways, but this is all you need to know for this. This is the most modern way, and I think the most flexible, but that's just me. So how do we make it dollars? we put in $1 in front of it. That one's actually pretty easy. You just put $1 in front of the number. Because that's not part, that can, in some languages, that is part of the formatting. There's really not a dollar formatting in Python. But some languages do have a dollar formatting, a currency formatting. And Python may have a currency formatting library, I don't know. Like in South Africa, you have a different currency than we do. You wouldn't have a dollar sign. So if you wrote an international program that had to work in many different languages, you could have general rules that say, if I'm in South Africa, I use this and I use this. If I'm in the United States, I use this and I use this. Like all windows, you can switch to different languages. Sometimes I get screenshots that are in Spanish or something. It's like, okay, oh, now I can understand the code, but all the rest is in a different language, which is fine. But that's probably beyond what we need to talk about today. But programming does allow for a program to be written and you'll see the right currency for your language. This we're just hard coding dollars for the United States. What is your currency in South Africa?
It's called ZAR, but you would call
ZAR.
it Rand.
It was what?
Rand,
It's called Rand?
yeah.
Okay.
But if you had to search, like, because Rand can mean anything, can be ambiguous. So specifically, ZAR is ZAR.
So is it kind of like if we say money, but dollars is maybe not?
You can say rands, like I have 5,000 rands.
Okay,
Yeah, I have 10,000 rands, like $10,000, you know. Yeah.
okay.
And
Alright.
like maybe 10,000 rands is about maybe $500. So,
Okay. Not a good exchange rate, is it?
no, I think for every dollar it's about 19 rand, I think. So that's how many people like they do Forex or stuff like that. Yeah, they get money from here and then when it converts, that's how it exponential growth.
Okay. All right. So everybody good with this guy? Makes sense? Everything's gonna follow this same pattern. I mean, every program I write looks like this. So after a while, as a developer, you develop a style of coding.